Okay, welcome back. So look at part 2 of set theory, and of course in part 2 of this set theory we are looking at Venn diagram. Okay, Venn diagram of course is using a diagrammatic expression to express set theory. Now, and I will go straight to the point. I will not want to waste my time on that. Now let's assume that you have represent the following with a Venn diagram. So maybe the first one I have set A, second one I have A prime, third one I have A union B, the fourth one I have A intersection B, the next one I have A union B prime, the next one I have A intersection B. Let's say this is what I have, A prime union B prime, then A prime intersection B prime, then let's say I have A prime union B, then 8 I have A union B prime. Let's say I want to represent all of this with a Venn diagram. Okay, now looking at this, look at the first one. First one is set A. So if I want to do that, of course I'll first draw this. You see that? So then I'll draw set A inside. Because it's set A I'm looking at, you shade the set A inside. Now this one is representing the universal set. The box is the circle that is representing the set. Okay, now for number 2, A prime. Now if I want to represent A prime with Venn diagram, I have set A. Now anything prime means don't touch, don't shade that letter. So A prime means A is not there. So you are shading outside A. It's not there, outside A. Shade every other place but don't touch A. That's the meaning of the prime. Then the next one, which is number 3, you have A union B. Now your A union B, you will have this A and then B. So A union B means A and B together. So you shade everything. You shade everything. You see that? A and B together. A union B. Then number 4 is A intersection B. A intersection B means you have your set A and your set B. You shade in between. Intersection means common element. The place that is common to both of them. That's where you shade. And then number 5, you have A prime union B prime. Now A prime union B prime, now you can re-express it as A intersection B or prime. You see that the union will change to intersection and then you bracket it and give it 1 prime. You call this De Morgan's law. De Morgan's law. It's a law of set. De Morgan's law. So De Morgan's law is saying if I have A prime union B prime, it's the same thing as A intersection B or prime. So if you want to do that, if you want to express that with Venn diagram, you'll be having something like this. Set A, then set B. You see that? So A intersection B, not there. So you are shading this place. You are not going to touch the middle. The middle here. Are you with me? So intersection means don't touch this place. Intersection prime. This is intersection. But because it is prime, don't shade that place. That is intersection. Then number 6, you have A prime intersection B prime. A prime intersection B prime. Using De Morgan's law, you also have it as A union B all prime. So if I want to represent this with Venn diagram, I'm going to have this. And this is my A, this is my B. Now, what this means is that A union B, don't shade it. That's why you have the prime. You shade outside A union B. Outside. You don't touch the inside, A union B. Okay? And then, number 7, you have A prime union B. A prime union B. Now, A prime union B, look at this. A, B. So A prime union B means don't touch A. Only small part of A is what you should touch. You know you have union. So I'm going to have just this. That is shade the whole of B. You can see that you are just shading the small part of A that falls inside B. Don't touch A. Only small of it. But let's assume that we have A prime intersection B. Look at this. A prime intersection B, something like this. So A prime intersection B, which is number 8. A prime intersection B will now be, this is the universal set. You have A and B, and then so you have, don't touch A at all. Don't shade A at all. Now, why is it that you are shading little part of A here? Because it's union. But in this place where you have intersection, don't touch A at all. You can see it. I'm not shading A at all because it's A intersection. But when it is A union, A prime union, you shade little part of A. That's the difference. Okay. Having said that, this one is for when you have 2 sets. Now let's look at a situation where you have 3 sets. A situation where you have 3 sets. How do you do the Venn diagram for 3 sets? Now, how do you do the Venn diagram for 3 sets? Now, we're going to do that together. Now, doing that together, I'm going to draw a big look at this. So let's say this is set A, set B, and set C. So if I have my universal set like this, let's say this is my universal set. You see this? Now, the representation of this one, I'll be doing it inside. Now, if you look at this now, where I put my hand, you see, if I trace the circle of B, it does not get to my hand. If I trace the circle of C, it does not get to my hand. So it means this place is A. So B is not there, C is not there. You see that? Prime. Then, if I put my hand in this place, you know, if I trace the circle of A, the circle of A, my hand is inside the circle of A. Look at the circle. My hand is inside the circle of A. If I trace the circle of B, my hand is inside the circle of B. But if I trace the circle of C, my hand is not inside the circle of C. So it means it's only A and B that is here. A intersection B, intersection C prime. That prime means C is not there. Now if you look at this place, look at my hand. Tracing the circle of B, my hand is inside the circle of B. Trace the circle of A, my hand is not there. Trace the circle of C, my hand is not there. So since my hand is only circle of B, that means A is not there, B is there, C is not there, C prime. Now if you look at this place is for the 3 of them. If you see my hand here now, if I trace the circle of A, my hand is there. Trace the circle of B, my hand is there. Trace the circle of C, my hand is there. So this middle is A intersection B intersection C. Now look at this place. Excuse me. If you trace the circle of A, that circle is not getting to my hand. If you trace the circle of B, it is getting to my hand. If you trace the circle of C, it is getting to my hand. That means it is only B and C you have here. So A is not here, but B is there and C is there. Then if you look at this place, here, the circle of C is where my hand is. If you trace circle of B, it's not getting to my hand. Trace circle of A, it's not getting to my hand. That means A is not there, B is not there, and C is there. You see that? So, and if you look at this last part, this A is there, intersection B is not there, intersection C. So you might be asked, you might be given a question that represent A intersection B prime intersection C prime with a Venn diagram. All you just need to do is to come and shade this place. Or if they say represent A prime intersection B intersection C with Venn diagram, all you need to come and do is just to shade this place. I hope we are clear with that. And of course, this outside means A, B, and C, all of them are not there, which is the same thing as A prime intersection B prime intersection C prime, De Morgan's law. So with this, I have come to the end of part 2 of set theory.